Welcome to this lesson on rational functions. In this lesson, we summarized our learning of rational functions through a breakout activity as well as previewed oblique asymptotes. Let's start with this warm-up. Consider the two functions below, f of x and g of x. Will f of x and g of x have the same graph? Explain your reasoning. Pause the video to think about it. So here are the two functions. Let's see what you came up with. You may have discovered that the functions would look the same when graphed, but they're actually not identical. F of x would have a hole at -3 because these two factors cancel. Whereas g of x may be that simplified function, but there is no hole. So let's take a look at each graph on Desmos. Here is our function for f of x, and here is our function for g of x. They look nearly identical. However, if we look and focus on f of x right now, and go to the value of -3, we would find that it is undefined. There is a hole. Desmos does not show you this, so we must always consider it. We can also consider if we type in f of -3, it will tell us that it is undefined. So we should indicate it with a hole when we graph it. It's important to be careful with these characteristics. So as mentioned, we're going to preview the idea of oblique asymptotes, but before we do that, we need to remember simple problems like this. Would you know how to divide this without a calculator? Rate yourself. So let's take a moment to review how long division works from elementary school. Here are our steps. First, we're going to divide the 6 into the first possible term. So in this case, it's 21. 6 goes into 21 3 times. So now we can multiply and subtract. 6 multiply 3 gives us 18. So when we subtract 21 minus 18, we end up with 3. Now we will bring down the 7. And we will start the process all over. 6 into 37 is 6 times. So we will continue the process. 6 multiply 6 is 36, and we will subtract and get 1. Because there is nothing left to bring down, our process is finished. We have our result. 36 with a remainder of 1, or 36 1/6. So why are we worried about long division right now anyway? Well, let's think back to a previous lesson. We talked about what causes horizontal asymptotes to be at 0 or another value. We related that to the degree in the numerator and denominator. But there was one scenario we did not address yet. If the degree in the numerator is larger, or top-heavy, the horizontal asymptote is oblique or slanted in the form y equals ax plus b. Long division will be a helpful tool for this. Slant asymptotes may look something like this. So in our case, because we're dealing with rational functions, we are considering polynomial long division, which you may have learned in Algebra 2. So here are our steps. Our first step will be setting up the long division with terms in standard form and filling in missing terms with zeros, if necessary. We will then divide the first term of the dividend by the first term of the divisor. Similarly, we will continue to multiply and subtract, and we will bring down the next term and continue the process. So now we will see some examples. So let's divide these two expressions. So first we must set up our division. Notice our x minus 2 is on the outside. Now we will divide. And when we divide, we will divide the first terms. 3x squared divided by x, which is 3x. Or you can ask yourself, what do I need to multiply x by to make 3x squared? So now we will multiply and subtract. X multiply 3x is 3x squared, And we must multiply the negative 2 with the 3x and get negative 6x. And now we will subtract. Be careful with the subtraction here. 3x squared minus 3x squared should cancel out if we did this problem correctly. But now 5x minus negative 6x gives us 11x. And now that we subtracted, we continue and bring down. So we must bring down the minus 4. Once we bring down, we start the process over again, starting with the division. 11x divided by x is 11. Or what do you multiply x by to make 11x? So now we will multiply and we should get that term, 11x. And then negative 2 multiply 11 is negative 22. Be careful with your subtraction. 11x minus 11x cancels like we wanted. And now negative 4 minus negative 22 is 18. And there's nothing left to bring down, so our process is finished. Our result is 3x plus 11 with a remainder of 18. We have one more example. Let's divide these two expressions. We'll set up our division. Notice we did not have an x term, so we used a placeholder of 0x to not mess up our process. Now we will divide. 2x cubed divided by 2x is x squared, because when we multiply 2x and x squared, we would get 2x cubed. We must also multiply negative 5 by x squared. We get negative 5x squared. And now we subtract. The first terms cancel as desired, and now negative 9x squared minus negative 5x squared is negative 4x squared. Now we have a 0x to bring down, and we repeat the process. Negative 4x squared divided by 2x is negative 2x. So when we multiply, the first term is negative 4x squared, and then negative 5 multiplied negative 2x is positive 10x. We will subtract. The first terms cancel, and 0x minus 10x is negative 10x. Bring down the 15 and continue the process one more time. So negative 10x divided by 2x is negative 5. So now we multiply. 2x multiply negative 5, and negative 5 multiply negative 5. One last subtraction. The negative 10x's cancel, and 15 minus 25 is negative 10. So our result is x squared minus 2x minus 5 with a remainder of negative 10. So keep in mind, we reviewed polynomial long division for the purposes of investigating oblique asymptotes in an upcoming lesson. This is a necessary skill from Algebra 2 that we will need to graph this type of rational function.